Hey there guys, so today we're gonna try out Brainpan from TryHackMe. So this machine is basically perfect for OSCP practice, so we are highly recommended to complete this challenge before we go to OSCP exam. This one is more to buffer overflow vulnerabilities by analyzing the window executable in our Linux machine. So let's try it out. So over here I have performed a scanning already, and normally we will saw SSH port right open, but in this case it doesn't show. It show a 999 port with, it seems like a binary running over there, and then 10,000 port is a HTTP port. So we try to check the 999 port first. Okay, the IP, and the IP first. Okay, get the IP and then 999. Okay, welcome to Brainpan. Enter the password. Enter anything else. Access denied. Okay, interesting. Okay, so now let's try to check and see with the 10,000 port. Okay, so are you practicing safe coding? Okay, now we leave it there first. We try to perform fuzzing first. Only we try to read it. Okay. This one I'm gonna use BRB. The common word is to perform fuzzing. Okay. I forgot to mention the fuzz to word. Okay, we perform fuzzing over here first. Okay. Vulnerabilities, blah blah blah. We try and check and see the source code. It sounds like an image in it. We try and check and see the image. Okay, just an image, not any other directory. Okay. Okay, let's check it out with our fuzzy. Okay, it seems like it found a bin directory. We check and see with the bin directory. And we found a Windows executable program, Brainpan. Interesting. Download it. Okay. And then move it to here. Okay. Yeah, we got our Brainpan over here. Brainpan PE32 executable. Okay, so let's upload it to my Windows 7 machine. Check my IP first. Okay, 150. That's the alliance. Brainpan. Okay, upload it already. Seems like initialize WinSock. Okay, server socket connected. Bind done on port 9999. Woof. Seems the same order. Okay, we try to connect into our local machine, the Brainpan program. Yup, it's the same. So the program that running in the machine, in this machine, is the same as the one that I'm running over here. So we can try to check the vulnerabilities over here before we execute the real code in the remote PC. So right now we try to analyze it first. We try to check and see, does this one vulnerable to buffer overflow or not? If it's vulnerable to buffer overflow, it might crash. So we create our Python script first. Okay, we import a socket, and then the host is, I'll put my local machine host first, and then the port is 9999. Okay, so we initialize the socket first. And then over here we connect into it. And then here is our padding. Now we put ABC, some example, and exploit, we put padding. Okay, and then over here we need to print first. See, exit to 4, and then send it out. This one put exploit plus new line tag, and we print aside RCE 1024. So over here we try to receive the string first, and then only we send it and see does it receive any response over here or not. Okay, we close it, close the socket. Now we try to perform the exploit. Okay, so first we receive one, and then this one is after you send it only receive this code. So over here it seems like we successfully connected over there. See? Okay, ABC. We got ABC over here. So right now we try to send our string, our cyclic, we call it, or I call it as a padding. So we use this one, the pawn library. So this one, okay, first. Okay, from import this one, cyclic. I need to generate 1000, so I can check and see will the program crash or not with this much of padding. Okay, and then send it out. It starts over here, and it shows brainpan.exe has stopped working. Okay, for module name stack hash. Okay, it seems like this program is vulnerable to buffer overflow. We try to check and see with immunity debugger. So we dump it over here, we run it and run it. Okay, connection reset. So send it out again. Okay, it seems like access violated when executing this one. It seems like we have overwritten the EIP address, and here's the EIP 66616167. So we try to find this one. We try to find this one in here. How can you do want to let me go there? Okay. So 66616167, right? 66616167. Okay. Now we enter. 524 is the padding. Okay. So this one to close it first because the string is way too long. So we put A times 524 or something. Now I put it first. Then only exploit equal to padding. You save it, and then over here check 524. Okay, so now we need to check and see does our padding correct or not. We add BBBB, which will be 42 if we successfully overwritten the, what's that called, this one, the EIP address. So if we successfully return it, so it will be 42424242. Okay, we attach this one, play it, and then we try to send it. Oops, invalid syntax. I forgot to put my equal sign. Okay, 42424242. Okay, we have successfully overwritten the EIP, so we have found the padding for it. Now we need to find our jump ESP, the address first, because later on we will put our shellcode inside the stack and we need to jump into our stack to execute our shellcode. So we're gonna use Mona jump ESP. But before that, we need to check with the modules first. Okay, so brainpan.ext, this is the one that I need to use. So I need to find the jump ESP address inside brainpan, and we need to make sure that all this one must be false, and we can perform the execution. So we need to close this one first, and then wanna jump ESP brainpan.exe, and where is it? Okay, here's the log data. Okay, you'll find any, and check and see first. Yeah, we found one jump ESP address. So the address is this one, 31171253. So we need to enter it reversely because it's little endian. So jump ESP address is F312. Oops. And then 1731. 3121731. Okay, and then we need to put the X because this is hexadecimal, and then we try to put this one first, plus jump ESP and plus BBBB. We try to check and see, and over here still can run it, right? Okay, now we try to send the exploit, and we see where did it go. Oops. I need to find where does it stop first. Maybe start this one first. Okay, delete it, search for all references taxes. Okay, play it. Waiting for connection. Where's the waiting for connection? Here is it. Okay, we find the return. Where's the return? Here's the return. So we put a breakpoint over here, and then we try to send it. Oops, it doesn't break over there. Never mind. Try to send it again. We need to find. Let me try and see. Does it jump into our jump ESP address now? So over here, search all references taxes. Shitstorm. This must be somewhere over here. I think I put a breakpoint over here first, and then send it again. Yep, we found a breakpoint. Okay, so it jump when it reaches one. The EIP address is 31711362. So this is the same, 311712F3. Hold on a second. 1362. Am I? We go first? Yeah, correct. Because I demo again. Okay, send it out again. Okay, this one 31171362. This one, yeah, see over here, this one is our, what's that called, our jump ESP address. So later on, where is this? That's the part it will show. No. Okay, I know why. Because I forgot to remove this one, so it confused with my padding. That's why I feel weird. Okay, now mind. Reset it again. This time it shouldn't be a problem. Okay. Yeah, see, jump ESP, and then we will end up in 0285930. See, we end up in here. So we can put our shellcode over here and we execute our shellcode. So this is how it should be. This one I forgot to remove my extra padding over here. That's why it confused me. So over here, before we put our shellcode, we need to put some buffer over here. So this one I put 16 of this one, the node, and then plus buff. So now, but before we find this one, we need to find some bad characters first, because bad characters might terminate our shellcode, right? So we need to find the bad characters. So bad car. And no, not this one. Okay. Over here I need to restart it again. Okay. Enter this one. And then where is it? This one I need to find. Try and see if I can find now. Which one is it really? I think this one. I need to follow. This part. Follow in dump. Flying the dump. Okay. Is this the part? Yeah, this is the part. So this is our bad characters checking. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 10 is missing over here. Yeah, the 10 is missing over here. Seems like 10 is a bad character. So now, oops, no, 10 is not a bad character. Seems like we removed already. Actually over here it must be a A, because this 10 right in hexadecimal. Okay, we restart it again first. Probably I didn't check my bad characters code, so it should. Okay, we run it first. Okay, and then follow in down. That's how it should be. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0 A, 0 B, 0 C. Okay. Until FF, no? Yeah, until FF. So it seems like the only bad characters over here is this one. The bad character is this one, because in C, right, actually this one is a string terminator, so this one is a bad character. It will terminate our shellcode, so we need to prevent this one in exist in our shellcode, so we need to remove it. Never mind, we want to save our time while we remove that one. Use MSF random. And then this one I need to, because I need to test it out, can I execute my code? So Windows, execute, CMD, this one I put calculator, .exe. Yeah, I put ESP, and then this one is Python, and then this one is the bad character. And then I save it as POC dot py. So while generating it, we remove this one first. I think I use the GUI is better. Okay, so this part I need to remove it. Then later on, this one will be my shell code. Still haven't finished generating. Never mind, we wait for it first. So okay, successfully generated. This one POC py. Place it over here. So this one we need to change buffer. So padding this one, and then we jump ESP, jump into our shellcode. Okay, this one we put some buffer over here, and then we execute our buff. This one our shellcode. So over here we will execute calculator. So it should shows a calculator in here. So we try it out. I'm trying to play this one first. Send it. Okay, we play. And voila! It seems like we successfully spawned a calculator. So we have successfully executed our shellcode in our stack. So we perform a buffer overflow in stack. So now it's time to play around with the real machine, which is this machine. So now, but this one is a Linux, right? So we need to change a little bit with our shellcode this part. So later over here I will test with this one. Linux execute calculator.exe. This one I will be ping t okay, I run it first, and then here and to remove it. Okay, so invalid. Okay, this one must be x86. So now we need to wait for it first. We're gonna wait for a while for it to generate it. Okay, it seems like it's successfully generated. So now I will open over here later. Open my Wireshark. And check and see the code first. Here. I want to send only one. Okay, it's count, not T. It's count C. So I need to change my shellcode again. C. Okay, we wait for it to execute first. And then this one, we need to use this one, the turn 0. So we try to listen. If later on we successfully execute the code, right, we will get our shellcode over here. Shellcode. No. You will get our ICMP packet response over here. Ping to us and receive the ICMP packet over here. Okay, now, okay, we have successfully generated. So let's try it out. That's my POC. So shellcode, we save it. Python exploit. Oops, I forgot to change this one. This one will be the remote host IP. So this IP, Okay, the IP is this one. We save it, and then we try to send it, and we check and see with the ICMP packet, and yeah, the source ping to us, and we reply the ping. Seems like we have successfully executed the code in remote server. So right now we can get our reverse shell using this one. So how can we get it? This is the best part right now. We use this one. We just delete everything else first. Okay, so over here we use the shell x86. This one is reverse TCP because I don't want to use the metasploit, the interpreter. I want to use my netcat to get it. So the L host is 10.9.10.47. L port, I will set it as 18890. Okay, we check it out first. The payload is Linux x86 reverse TCP. L host is my IP. L port. Okay, I'm going to open this one first. Open over here. Okay, so Python. Okay, we execute this one, and we wait for it to give us the shell code. So, no, I don't want to save. Stop. Quick without saving. Invalid payload. Okay. I think it's something like this, right? Shell reverse TCP. We check it out first. Yeah, it's shell reverse TCP. So you'll see. Oops, no, close without saving. Okay, we get this one, we change this one over here, and then we run it. I think I need to run it over here button. And voila! We have gotten our reverse shell. Interesting. So we spawn this one first, the interactive shell, the pty shell, pty.spawn. Okay, we are in part user. Where am I? Part. Okay, ls. Now we have to check sudo -l. And it seems like we have one binary we can run it as root, which is this binary. Okay, sudo, we no need to execute any password, we can run it as root user. Okay, so it seems like this one we can perform some action. Perform the network first, and then we perform prop list. Okay, nothing special. How about we perform manual? We perform manual. I put man, command, right? Okay. Manual page man 1. Okay, press H for help, press Q to quit. Interesting. It seems like we can abuse the manual page. This one I put ID for example. Okay. Bin bash. And voila! We have privilege escalate to root user. So who am I? Root. So okay, well there's a bit of things here. Try read and see. Brainpan. Okay, voila. So it seems like we have successfully owned Brainpan. So if you guys want to take OSCP, do remember to try Brainpan in TryHackMe. This one really helps you a lot in buffer overflow, like binary exploitation those. So thanks you guys. Bye bye.